All attendees are in listen-only mode.
Hello, my name is Victoria Price. I'm a technical sales engineer at QPS. Today I'm going to discuss how QPS products can fit into a workflow that's geared towards fisheries ecologists. Three-dimensional and four-dimensional visualization is powerful for effectively communicating data to a broad audience. We grasp concepts more fully when we see them in a context that relates to the way we experience the world. This allows for a more holistic approach to data exploration and a more informed decision-making process. With fisheries data, allowing for four-dimensional visualization can provide a little bit of insight into the species distribution, biomass estimates, understanding of behavior, habitat utilization, predation, time-related distribution, and other things. This data set that's playing right now is a pretty basic example of that. We have multi-beam bathymetry from Horizon 7125 and water column data that was collected with the same system. Now, if you were to look at each individual set of data on its own, it's not really as meaningful for interpretation as both of them integrated together. Incorporating not only habitat information in terms of the shape and characteristics of the bathymetry, you see this ledge, but also biological information in terms of the location and distribution of targets that we know to be fish. These are Creole wrasse on a bank in Flower Garden National Bank's Marine Sanctuary. I'll start off with a little bit of an introduction to the QPS suite. We have an acquisition package that's Quincy. We have a processing package that's Chimera, that's new. And our visualization package, Fledermaus. Chimera is our new bathymetry processing tool. Our goal was to create something that's fast, that's intuitive, that's easy to use, and especially easy to train. We wanted something that someone could learn quickly and feel like they fully understood and could also teach to others quickly. So if you've got interns, students, it's very easy to pass that information along. Chimera also has functionality for near real-time processing and is cross-platform. So for those of you who aren't familiar with Fledermaus, it's a tool, or really a package of tools, designed for geospatial data integration, analysis, and visualization. There's functionality for time series modeling. There's the fourth dimensional element in there. You can integrate your bathymetry, backscatter, water column data. If you have site samples, imagery, there's a lot of possibilities and a lot of ways to really get creative to achieve your visualization goals for product creation and information sharing. This is another example of a Fledermaus scene. It's actually just off of Portsmouth, New Hampshire, where our U.S. office is located. We have a couple of large multi-beam bathymetry data sets. There's backscatter and there's imagery. And then to put all of that in context, there is large-scale satellite imagery. When you think of a general workflow, you need to start with collecting data. From there, you need to process the data, clean up noise, do you find any issues and correct them, and so on. And then you need to determine what this data is telling you. What does it mean? And what do you want to do with it from here? What products need to be created? What's your ultimate goal for communicating what all of this data means? And each step of the way, you also need to manage and organize your data and distribute it. If we want to be a little bit more specific, and more specific particularly to fisheries work, it's helpful to bring in multiple tools. One especially powerful workflow is incorporating the water column data processing and also analysis functionality of a program called Echoview. Just hold on a second, we've got a little... So you start with your water column and bathymetric acquisition, which are separate but complementary processes in Quincy if you want to stick with the QPS suite. You can have your processing of the bathymetry in Chimera, which is straightforward, it's easy, it's fast, and it's simple. You can do your water column processing in Echoview. You have customizable workflows depending on what your goals are and a really, really vast statistical toolbox. And then from there, you can do your visualization in Fledermaus, determine what your ultimate goals are for product creation, and then share that data. And then you have your data management aspect in ArcGIS. You have tools for geospatial statistical analysis and also for managing large data sets. I'm going to give you guys a little bit of an example of Chimera. So I've brought in that Reason 7125 data from that data set that you just saw. I cleaned it up a little bit. I already did most of that. We have a multitude of editing tools. We have a swath editor, a 3D editor, and a slice editor. Most people are pretty familiar with the 3D editor in Chimera. So you can look at your points, you can clean up your surface, and a surface that has water column associated with it, specifically looking for fisheries. For fisheries work, you're going to see a lot of noise in this data set. This has already all been cleaned out, but you'll see spikes that are associated with fish in the water column. For those of you who aren't familiar with the Echoview program, it's a really powerful tool for water column processing. Like Chimera, it features non-destructive processing, so any editing that you're doing to your data is not actually being done to your raw data. This means that anything you do, you can also undo. It also provides a really useful visual workflow, so you can see, you can also communicate what steps need to be done to your data, so you can pass along one of these projects to anybody, and they can plug in the data, and it will run through this workflow that you see. It also has a very extensive statistical toolbox for processing algorithms, and you can visualize in multiple windows what you're doing. So if you're running each of these bubbles, you can open each window and you can see what's being done to the data as it's being done. So you can also integrate multiple sensors. If you've got fisheries echo sounder data for multiple frequencies and multi-beam data, you can visualize your data at each step of the process, and that allows for more effective decision making about what steps come next. And you can export valuable information about biomass estimates, abundance, and distribution. Here we have an example of EK60 data from 38, 120, and 200 kilohertz transducers, as well as the 7125 data. This is the same data that you just saw in Chimera and that you saw in the video earlier. If anyone has any further questions, I'd encourage them to talk to Toby Jarvis from Echoview. He's a great resource, and he has a lot of knowledge on fisheries acoustics. Now, in Fledermaus, there's a tool called FMMidwater, and that extracts and visualizes water column data. You can also apply navigation, and all of that gets turned into a generic water column format. So in FMMidwater, you can bring supported raw data, and it converts it to a common format, a GWC or a generic water column. This also allows for concatenating of multiple raw data files, and you can also subsample or compress your data. You can also allow for external navigation integration. With the end goal being the extraction of features in the water column, the process is pretty simple. You import your raw sonar file, you can convert it to a GWC, and you can run the feature extraction tool, which is equipped with a variety of filters, like normalization filter, despeckling filter, side lobe suppression, or you can identify features manually, and then you simply export as a Fledermaus SD object, which is a scientific data object. You can export beam fans, beam curtains, snapshots in time. So if you don't want the full 4D beam fan, you can have just one particular point in time. You can export point objects, volumes, so schools or plumes, and you can also export points as ASCII files. And then you can bring all of that information into a Fledermaus seed, integrating it with other data types to form a coherent data set. And this is an example of a data set that's from CCOM. It's SEEP data, and you see the backscatter from the SEEPs as volume objects, the fan, and then the backscatter draped over the bathymetry. And I'll show you guys a little bit of midwater. So you can, once you bring in your raw data and you convert it to a GWC, you can look at it in a few different ways. You can apply masks, and you can also just look at it over time. So the time bar that's in Fledermaus is very familiar, and it's exactly the same in FMMidwater. You can look at your data in a stacked view, in a beam view, and then you can export it. So there's a variety of different export options. You can export it as a snapshot, as a time series, as a vertical curtain if you've got single beam data, or as a beam curtain from a particular beam. From multi-beam data, you can export points or point clusters if you've got targets in the water column. And you can also export your ship track line and a bottom track line. In Fledermaus, integrating multiple data types is pretty easy. You can incorporate point data, line data, DXF or DWG AutoCAD data if you've got models of an ROV or a vessel. You can bring in imagery, vertical images if you've got sub-bottom profiling. You can also bring in imagery collections from HabCam stills or from like benthic grab sites. You can bring in shape files, S57 ENC files, and you can also bring in video. You can also create scalars from your data. You can calculate backscatter, you can calculate rugosity, and you can calculate slope. So what I did was I took some of those points from Echoview, those targets, and I exported them and I brought them into Fledermaus. So now we have our water column and our bathymetry, but we also have this important information. These are all fish from Echoview, and they're colored by target strength. So we have a little bit more information on what's in the water column and how they relate to the habitat around them. We can play that. And as the fan's moving through, you can see stuff moving. These are a few other examples of ways you can get a little creative with data integration. The top image shows ADCP cast point data with backscatter overlaid in bathymetry. The bottom image shows habitat imagery of benthic fauna, sponges and some crabs overlaid in the bathymetry. And it gives you a really good look at what those high relief areas popping up in your bathy actually are. And it also gives you some contextual information. If you're doing HabCam work, or you have like GoPro video, picking up ground truthing for biomass studies, that sort of thing, we can also integrate video. It's especially powerful for ground truthing on ROV studies. If you've collected backscatter, you can also pretty easily mosaic that in FMGT and bring it into the main Fledermaus module for visualization. This is some really interesting backscatter that was collected over fish traps. When you drape that backscatter over bathymetry and add in some water column data, you get a really interesting look not only at the structure of the traps and what they look like in a three-dimensional realm, but you also get an idea of what's in the water column swimming around them. Another powerful functionality in the Fledermaus package is ARC integration. You can connect to an ArcGIS database directly from Fledermaus. This allows you to read and write to that database. I like to have ARC catalog open on one monitor and Fledermaus in another, and I can just move right back and forth between the two. You can export your bathymetry, your scalars, or you can bring in rasters and vectors and shape files from ARC. Information that's useful for visualization or useful for data management and map creation, such as soundings, contours, mosaics, water column target points, like the ones I exported from Echoview, can be moved back and forth this way. Makes using all of this data that you've analyzed for geospatial and geostatistical processing in ARC really simple and really fast. You can bring those results right back into Fledermaus to add to your scene. If you then want to create fly-throughs or create a movie or share the data. And I will show a little bit of that. This is some backscatter. We've also got the bathymetry and the rugosity. I've created an ArcGIS workspace here, and I've connected it to an existing geodatabase, so I can open rasters that are in this geodatabase, or I can, from my object attributes, transfer a survey area, your bathy raster, any imagery that you have, or scalars like the rugosity or your backscatter to that ArcGIS database. And then you can open them in ARC, either an ARC map or ARC catalog, whichever you prefer. So all of those get written in, and they're immediately available. So now you have all of your toolboxes for geostatistical analyses, any cartography tools that you might want. Here's just some more examples of this. You've got your survey areas, a shapefile, sounding points, you've got your bathymetry, your backscatter, and all of those are visible in our catalog as you're writing them to that geodatabase from Fledermaus. So why is all of this important? Mapping can integrate much more than just bathymetry. Incorporating fisheries ecological data is helpful for many different application areas. You can use these layers for habitat mapping and as a base for object-based image analysis. You can use the data for visual, easy-to-interpret species distribution maps or site suitability modeling. An example of this is aquaculture site planning. You can use this information to determine essential fish habitat, or you can incorporate it into a CMEX model. CMEX is the Coastal and Marine Ecological Classification Standard. Really, any way you might want to be able to look at your data in a way that makes sense visually, there's a way to do it here. Visualization adds meaning to your data. It's not only useful for creating effective figures for publication, but also disseminating information for collaborative efforts, to clients and to managers at various levels. It's also a very powerful tool for public outreach applications, especially in the context of fly-throughs and movie creation in Fledermaus, like what I displayed earlier. And with that, I'd be happy to take any questions. not sure if anybody's had any questions, but Chris Malzone, who's the general manager in the US, is available. You can also call me at any time or email me at price@qps-us.com. And if you have any questions or you want a demo or are curious about the full functionality, please let me know.
That's Victoria. We had a quick one. Alex Barnard. He says, "Are there snippets still in Fledermaus?"
Hold on one second. In what context?
Alex, I believe you're talking about snippets as in regards to the backscatter format for the CVAT systems or the RT Sonics.
Yes, there are. Yep.
Then also Frederick Schroeder asks, is it possible to clip WCD below the bottom detection in the FMMidwater?
Yeah, and I can show you that right now. So in Midwater, in your beam view options, you can select any sort of beams that you want to look at. You can filter by range. So if you want to, if you've got a lot of surface noise or you want to clip out below the bottom detection, you can do that as well. You can adjust your depth. You can display in a stacked view as well over time. This takes a little bit of processing. So yeah, there's a multitude of ways to visualize, but it's very, very easy to filter out anything below the bottom detection. And then when you export, so anything that is visible, if you cut out points in the range, when you export something from this, only the data that's in the visible range will be exported.
And then also one quick thing, Jack Roberts was asking which ROV that was, and I can answer that question. That was the Saab vehicle, and I'm not sure which project it was for though. Pat Ian Pietro, he says, so in this example, Echoview was used only to export contacts points to Fledermaus. FMMidwater is used to process and display the beam pans displayed in the animation.
Yes. Yep.
Okay. And then Frederick asks, I meant to actually remove the data to save file storage space. I'm not sure what he means by that. And then Moshkor asks, can you please go over Echoview/QPS workflow? What are the types of files that QPS is expecting from Echoview?
So right now, Echoview exports a variety of different files, but we work most easily with ASCII formats. So in the little collaboration that Toby and I did at the Southeast Acoustics meeting that was a few weeks ago, he did all of the processing from that S7K data, did all of the pushing it through statistical algorithms to get target strengths from individual fish targets, and then exported that information as an ASCII. And then I brought that in to Fledermaus as points. As for clipping out information below the bottom line, that would not actually clip it out of the file itself.
And then Pat Ian Petra asks, is there a webinar or documentation bringing video into Fledermaus?
Documentation is coming, and that is actually a plan for a upcoming webinar. Watch your email for that. That'll likely be sometime in the next month or two. So yeah, that's definitely coming soon, and documentation should be on the Confluence page shortly.
Then Frederick asks, is that possible when recording with Quincy? I'm not sure what So interestingly enough, I did some testing with Quincy with some of the data formats with water column. So yeah, we could record the water column data in Quincy in both 8-bit and as well as the full the full beam data itself. So there's a couple of different formats. So both compressed and uncompressed.
I should reiterate that Echoview is not part of the Fledermaus or QPS suite. It's its own program. It's actually by Miriax.
Yeah.
We just found a lot of room for collaboration together.
Yeah, and then Jesper from R2 asked, do we have to purchase Echoview separately? We could either get that directly from Echoview, or we could get it as well and supply it. So we were able to supply that. Alden Denny asks, can you describe some of the target identification and cleaning tools in FMMidwater?
So the target identification in Midwater is pretty simple. Right now, it's a matter of filtering and thresholding. If you want actual target identification and isolating them as their own individual objects, then that would be done more in Echoview. So if you're looking at finding individual fish and creating discrete objects from those, then that's where Echoview comes in. In FMMidwater, it's more on the visualization end, so you can play around with your thresholds and then isolate things in a visual manner and export those as points. So you get a little bit of an idea. So you've got your raw signal, you've got your amplitude, and you can change your intensity thresholds or run like a despeckling filter or a normalizing filter to isolate I'm hesitant to say targets, but visual objects in the water column.
It's R2 2024. Okay, Frederick. Yeah, so actually, probably it'd be easier for me to get in touch with Frederick Schroeder myself and just answer his questions. He's got quite a few, and so you can just type in your email address, and I'll make sure I give you and your contact info. I'll get in touch with you directly. And I think I'm not sure. Oh yeah, okay, I got it.
And if anybody has any other questions, like I said, feel free to contact me. And I would be happy to answer them and give any demos, show you anything else that you'd like to see. Thank you all for attending and getting a little bit of an idea of some of the other ways you can use Fledermaus and how it fits into a complementary workflow with other products.
And we recorded this, and we'll send an email off to everybody after this with a link to that recording.
All right. Thank you.
Enjoy the rest of your afternoon.